Okay, class, so today we will be talking about nets for 3D shapes. You may remember doing netting for objects such as cubes or square-based pyramids in previous grades. Just to remind you, a net looks something like this. So for today, we will be discussing how to match a given net to a 3D object and how to make a 3D object from a given net. So, before you forget, when looking at a net, the very first thing you want to think about is how many faces are shown on the given net. So in this case, there is 1, 2, 3, 4, 5, 6 faces on this net. Now, given that information, you should be able to automatically deduce that it is a cube, but there are some other ways to figure it out. Before you forget, remember that each shape has a base. Now, in this case, because number 4 here is surrounded by 4 other faces, we can assume that the 4 square will be the base of this shape. Before we move on, I would like to point out that the official name for objects made from these nets are called polyhedrons, and common examples that you would be familiar with are the cube, a rectangular box, pyramids, cones, cylinders, and spheres. Another way to try to figure out what kind of polyhedron you will get from a net is to look at how many vertices it has. And a vertex basically means a point where 3 or more faces are meeting. So if you look here, there is 1, 2, 3 faces connecting right at this point. So we already know we have 1 vertice on this cube. And by that logic, we would also have 1 over here, 1 down here, over here, on this side, and over here. So that means that a cube would have a total of 8 vertices. So now, returning to our net from the very first slide, what 3D shape does this net make? Take a moment and try to figure it out for yourself. Let's just play this video here. And so as you can see, our estimation from the first slide, based on the number of faces that it had, was correct. It is a cube. However, just because it has 6 faces does not necessarily mean that this shape will always work from the given net. For example, can we use a different net to make the same 3D shape? If we move this square over on this side, will we be able to construct another cube? Well, let's take a look. This time, the cube was unable to be constructed. We ended up with this final shape. Can you estimate why? If you look closely, you will see that we actually end up with these 2 squares on the same spot, leaving an empty face on our cube. But that doesn't mean that there are not other nets that would work to also construct a cube. Let's look at another shape. What happens if we change the shape of the base? So in this case, we have a triangular base. Now, you may notice that we have the potential for a vertice here, here, and here. And we have 3 faces other than the base. So we can estimate, based off of that it will probably be a prism. But let's take a look. In this case, the net represents Oh, as we suspected, a prism. And based on the triangular base, it would be very difficult to attempt a separate kind of net. This will be the standard net that you would see for a triangular prism. Now, what about this case? It's not Pac-Man, as much as it may look like it, but it has an interesting shape, unlike the previous ones that we have looked at. And this is something new. You have not looked at examples of a circular base yet at this point. You may notice one issue. We are unable to count the amount of vertices, as circles have 0 vertices. But we can tell that there are some points of connectivity or edges. So we do have this area right here. And if we put this shape together, we would actually see a cone. And so today, for the rest of the lesson, we are actually going to focus not only on our previous forms of netting, but on how to net a circular-based polyhedron. Good luck!